Hi everyone, for today's lesson we are going to learn about our last 3 ways to prove triangles congruent. This is day 5 and 6 where we are going to talk about angle, side, angle, 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 side, and right triangle, hypotenuse, leg, which is going to be shortened into ASA, AAS, and RHL. Our learning targets for today are for you to be able to say, I can determine whether corresponding parts are congruent by angle, angle, side, or angle, side, angle. So you're going to be analyzing triangles and deciding whether or not they are congruent based on these 2 different postulates or theorems. And our second part is I can prove triangles congruent by angle, side, angle, 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 side, and RHL. Before we get started with this lesson, please make sure you have the following. You need some colors because I always use a lot of highlighters in my lessons. You're going to need a glue stick. Scotch tape works just as well. And you're going to need all of the cutouts for Unit 4, Day 5 and 6 interactive video lesson cutouts. You will also, of course, need something to write with. So if you need to pause the video to make sure that you have all of your materials, please make sure that you do so. The first thing that we are going to do is talk about angle, side, angle. So that is our first one, angle, side, angle. So if you wouldn't mind taking that out, that is going to be the first topic that we talk about. So please go ahead and glue it into your notebook, kind of glue it towards the side because we're going to use this side to write a few things. Alright, so what does angle, side, angle mean? It means that if 2 angles and the included side, remember that the word included, that means between. So it is the side that touches both angles. This is called the included side. It is the side that touches both angles that we are interested in. So if 2 angles and the included side, or the side that touches both angles, or the side that's between both angles of one triangle are congruent to 2 angles and the included side of a second triangle, then the 2 triangles are congruent. So what you're going to see are pictures very similar to what we have down here. So if you notice that angle A is congruent to angle D, and segment AC is congruent to segment DF, and angle C is congruent to angle F. This is angle, side, angle. Angle, side, angle. Angle, side, angle. Angle, side, angle. And all of your angles and sides are corresponding, meaning they match up with each other. Then we can say that our 2 triangles are congruent. Triangle ABC would therefore be congruent to triangle DEF. They would be congruent to each other. So if we're working with proof writing, we are going to use the shortcut of ASA for our proof writing. So this is our shortcut for proofs. If we didn't use ASA, we'd have to write this entire if-then statement, which is something I know you guys don't necessarily want to write because that's a lot of writing. So instead, this is what we are going to be working with, angle, side, angle, and that's our shortcut for proofs. So once again, I want to emphasize the fact that included means that the side touches both angles. So if we're talking about like BC, BC only touches one of the angles. It doesn't touch both angles. Same thing with like DE. DE only touches one of the angles, not both. So that side needs to touch both angles. All right, let's go ahead and take out our next topic, which is angle, angle, side. And once again, I would like you guys to please go ahead and paste this on the side so that I can use this space to do some writing. All right, so this next one is angle, angle, side. And if you see in two triangles that you have two angles and the non-included side. So the non-included side means we're talking about the side that only touches one angle. So the side only touches one angle. Not both. So if you notice that two angles and a non-included side, so our non-included side only touches one angle, not both. If you see that, and those sides happen to correspond with each other, because obviously there's three sides in a triangle. So we want to make sure that those non-included sides are corresponding. So if two angles and a non-included side of one triangle are congruent to two angles and the corresponding, so that is the key here, that angle or that side needs to be corresponding non-included side. So that means that it matches up of a second triangle, then we can say that the two triangles are congruent to each other. So I'll read that one more time. If two angles and the non-included side, meaning the side only touches one of the angles, are congruent to two angles and the corresponding non-included side. So that means that it's the matching side. It's very clear which ones are matching of a second triangle. Then the two triangles have to be congruent. So if you see that angle A is congruent to angle D, angle C is congruent to angle F, and BC is congruent to EF, meaning like BC would not correspond with DE. DE touches only one of the angles, but it's not the angle that we want. We want it to touch the angle that has two arc marks. So you have to be really, really careful. This side touches the angle with two arc marks. So it has to correspond or match. Then we can say that triangle ABC is congruent to triangle DEF. So it's all about matching. So it has to be the side only touches one of the angles, not both, and it must touch. So the side, I'm going to also come down here. The side must touch the same corresponding angle. So they have to match up with each other. Like this side touches the angle with two arc marks. This side matches the angle with two arc marks in order for both triangles to be congruent. So that's the thing that I really want you to pay attention to, is that that side must touch the same corresponding angle. And that is angle, angle, side. And that's what we use in our shortcuts. So we use angle, angle, AAS, angle, angle, side. This is our shortcut for proofs. And I say that it's a shortcut once again because if we didn't use it, we would have to write this whole if-then statement, and nobody wants to write that whole if-then statement. That is not something that we want to do. So what we want to do is the first part of the lesson, which is day 5, is all about analyzing triangles and deciding whether or not we can prove the triangle's congruent by angle, side, angle, or angle, angle, side. So what I'm going to do is I would like you guys to please go ahead and take out the examples, and if you wouldn't mind pasting this closer to the top, and then that will leave me space for my last cutout. So we'll go ahead and paste this closer to the top. We have ourselves a really quick example analyzing angle, side, angle, and angle, angle, side. So the example is asking you, can the triangles be proven with the information given in the diagram? The keyword here is can. Yes or no? Can the triangles be proven congruent with the given information? And if so, if yes, then state the postulate or theorem, which means it's going to be angle, side, angle, or angle, angle, side that you would use. So tell me what you would use. And so we're going to have to mark up our picture and really pay attention for vertical angles, reflexive property of congruence, etc. So let's go ahead and look at letter A. In letter A, I do see two angles that are congruent to each other. And I also see that we have vertical angles. We know that vertical angles are congruent. So I'm going to mark that up. I know that vertical angles are congruent. But I have absolutely no information about sides. I don't know anything about midpoint at this point. And so based on given information, I cannot prove that these triangles are congruent because this is an example of angle, angle, angle. An angle, 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 if you guys remember, is not a way that we are allowed to prove triangles congruent. We need at least one side in order to prove that triangles are congruent. So in this problem, it's a sad face. This is angle, angle, angle. And I always use that blue to represent an angle, 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 sadness. The answer in this case is no. All right, let's go ahead and look at letter B. Maybe this one will turn out for us. So far I see angles, and I see that they share a side. So I do see two angles and a side, and this side, of course, would be congruent because of the reflexive property of congruence. So we have the reflexive property of congruence here. So let's make sure that we have angle, angle, side, angle, angle, side. So here's my angle, and then a side, and the side only touches one angle, and then angle, and once again a side, and it looks like the angle that we're interested in and the side, they correspond with each other. The side touches the angle with one arc mark, the side touches the angle with only one arc mark again. So therefore we can say yes, we can prove these triangles congruent by angle, angle, side. This is an example of angle, angle, side. All right, let's go ahead and look at letter C. For letter C, I once again see vertical angles. Vertical angles we know are congruent, so we always mark those in. We are responsible for marking those in. And so I need to make sure that when I'm marking it up, I'm not using one arc mark because I've already used one arc mark. I need to use a different number of arc marks. I already have these tick marks here, so let's go ahead and analyze. I see angle, side, angle, angle, side, angle. So I'm looking at this being an angle, side, angle. So I'm going to say yes. We have vertical angles, which we know are congruent. And I see that we have angle, side, angle, so I'm going to say yes. we can prove these triangles congruent by angle, side, angle. So this is a happy face. So let me go ahead and go back to my original happy face and use nice bright colors, saying that this is happy yellow. All right, so let's go ahead and look at letter D. So for letter D, I see that we have right angles, which is nice. I see that we have a tick mark, which is nice. And I once again see those vertical angles. And so I'm going to mark those vertical angles up. So vertical angles are never going to be marked in for you. It's going to be your job to recognize when you have vertical angles that are congruent. And once again, we have angle, side, angle, angle, side, angle. And so yes, we can prove these triangles congruent by angle, side, angle this time. And I'm going to put a smiley face with in yellow because that's happy. So now let's go ahead and look at letter E. Oh, these triangles are not touching each other, so I really have to pay attention to what's going on here. I have one arc mark, I have one arc mark, that's an angle. I see a side, and it doesn't touch my angle with the one arc mark, but let's make sure that they're corresponding. I see that I have two arc marks right here and the side that it's touching, and I see two arc marks right here and the side that it's touching. So because the side that we're interested in is touching the same angle with the same two arc marks, these two sides are corresponding sides. So I'm going to say that this is angle, angle, side. Angle, angle, side. And we're talking about a side that's not in between the angles, and they correspond with each other. So I'm going to say, yes, you can prove these triangles congruent by angle, angle, side. All right, finally, letter F. Letter F, we have two sides and then an angle. And the sides, it's not side, angle, side. This is SSA. SSA. And we know that SSA is not a way to prove triangles congruent. We learned that before. So this is sad. This is an SSA. And we know that SSAs are a pain in the SSA. So this is a sad face. It is not side, angle, side, because the angle's not between the sides that we're talking about. This is SSA, and SSA is a pain in the SSA. We just have one more to talk about, and that is RHL. This is called hypotenuse leg congruence theorem. We call it RHL because the hypotenuse leg only works if you have a right triangle. So that is really important that that is given to you. So I'm going to put it about right. I might as well make it in the middle. There we go. All right, let's go ahead and look at hypotenuse leg, which we call the right triangle hypotenuse leg. So if the hypotenuse and leg of one triangle, of a right triangle, so it needs to be of a right triangle. That is really, really important. Now remember that hypotenuse represents the longest side, so that's really, really important. So if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg, which that leg needs to be corresponding because each triangle has two legs, so these legs need to be corresponding. Of a second triangle, then the two triangles are congruent. So in our triangles, it is really, really important because this is the only SSA that works. So that's what I would like you guys to write down. RHL is really SSA, but this is the only SSA that works. Otherwise, that's why we don't even call it SSA. We call it RHL. So that's what we use for shortcuts. But this is the only SSA that actually works. So I want you guys to just keep that in mind. And because we really want to steer clear of using that language of SSA, we don't even call it that. We call it RHL. So that's what we're going to write on the other side. We call this RHL, which is our shortcut for proofs. We don't even call it SSA, so I don't even want to see that on your paper. So let's make sure that we understand what the R, the H, and the L is. In your proofs, the R represents a right triangle. So in your proof, you're going to show that your triangle has one right angle in it. And as soon as you have a right angle, then we would call the triangles right triangles. So R represents right triangle. Here's Louise. So right triangle. So what you're going to see in your picture is you need to somewhere in your proof establish that your angle has a right angle. So that is your R. You need to show in your proof that you have a right angle. H represents the word hypotenuse. And what a hypotenuse is it's the longest side of a triangle, and it's always across from the right angle. So it's the longest side, and it's always across from the right angle. So that's your H. It is the longest side and always across from the right angle. The last letter is L, and that L represents the word leg. And the leg means one other side. So one of the other sides. It is not going to be the longest. It's just going to be a leg. So it could be this leg or it could be this leg. So both of those are considered legs, and it just depends. We want to make sure that they match up. So we're talking about L being the leg, and it's just one other side. And so this is the only SSA that works, where you have two triangles that would be congruent, where you would have a side, and an angle that only touches one of the sides. The side it will never touch is the hypotenuse. But if you can show this information in a proof, then you have proven the triangles are congruent by RHL. That is the end of today's lesson. If you have any questions over anything I talked about, please feel free to email me. Otherwise, I hope you have a wonderful day.